if n and m are positive integers, what is the remainder when 3 raised to the 4n plus 2 plus m is divided by 10? So this question has a lot of Gmat patterns on it, where if you were to see them for the first time, I would never expect anyone to recognize them. But if you were to see them then for a second time, after having learned it the first time, I would never expect anyone to not recognize them. And so what are those? So first of all, they're asking us for the remainder when we are dividing by 10. So that always stands out to me, because whenever they ask for the remainder when you divide by 10, it's sort of a special case. So I just wrote out 10 consecutive numbers here. And so what will the remainder be when I divide these guys by 10? So if I start with 20 and divide by 10, that will be 2 remainder 0. And so then up from there, my remainders will go to 9, and then they will repeat. And so once I get to 30, I go back to 0. And so this will be true for any number. The remainder when you divide by 10 will always be equal to the units digit. And so we can think of this question as just asking, what is the units digit of 3 raised to the 4n plus 2, all plus m? Now, another thing I recognize is I might not know what the units digit of 3 raised to the 4n plus 2 plus m is, but I know that there are, when I raise 3 to the anything, there's always going to be a pattern to what the units digit is. For example, if I just start at 3 to the first, so 3 to the first is 3, so that has a units digit of 3. 3 squared is 9, so that has a units digit of 9. 3 cubed is 27, so that has a units digit of just 7. And then 3 to the fourth is 81, so we got a units digit of just 1. So what this means is, so when I get to 3 to the fifth, so I just multiply this guy by another 3, what happens? Well, my pattern, I go back to the top, meaning 3 to the fifth should also give me a units digit of 3, and 3 to the sixth should be another 9, 7, 1. And so, from this, once you get 2 columns here, I can see, okay, so 3 to the fourth, 3 to the eighth, 3 to the 12th, 3 to the 16th, for example, all of those will have a units digit of 1. So we have 3 to the 4n plus 2. So let's just think, because they tell us n and m are positive integers. So if n is equal to 1, we have 3 to the 6th. If n is equal to 2, we have 3 to the 10th. If n is equal to 3, we got 3 to the 14th. So what does that mean? So it looks like no matter what, we're always in this row here for our exponent. And so therefore we know 3 to the 4n plus 2 will always have a units digit of 9. And therefore, in order to get our units digit overall, we really just need to know m, and not really just m, we just need to know the units digit of m, actually, although I'll take the whole value for m as well. So based on statement 1, so we just rephrase our entire question. What is m? Or if we wanted to, what is the units digit of m? Statement 1 says n is equal to 2. Well, what do we decide? So we already saw, though, n is irrelevant to our question because n is part of this exponent here. And we said, well, that no matter what, this exponent is always going to have a units digit of 9. So telling us anything more about n is not helpful. insufficient. M is equal to 1. Well, that is exactly our rephrase question. And therefore, so if we got a units digit of 9 here, and then we add 1 to it, overall we should have a units digit of 0, which should also be our remainder. So second statement is sufficient. B is the answer. A lot of sort of good Gmat tricks in this question.